Bismillahirrahmanirrahim. Assalamu alaikum. Our today's lecture is about decoder. What is a decoder? A decoder is a combination logic circuit that detects the presence of a specified combination of bits code on its inputs and indicates the presence of that code by a specified output level. So basically a decoder is a combination logic circuit. Inputs of a decoder will have a code, and the outputs will level the outputs will detect, the outputs level will represent one of the code pattern. Suppose for 2x4 decoder, and we will have 2 inputs and 4 outputs. For 2 inputs we will have 4 possible code patterns: 0 0, 0 1, 1 1 and 1 0. So the outputs, one output will represent one code pattern. In its general form, a decoder has n input lines to handle n bits, and from 1 to 2 raised to power n output lines to indicate the presence of one or more in bit combinations. Example of decoder: we have 2 line to 4 line decoder, 2 inputs and 4 outputs. 3 to 8 line decoder, or a binary to octal decoder, 3 inputs and 8 outputs. BCD-to-Decimal Decoder. So BCD code is 4 bits, so we will have 4 inputs, and decimal digits are 10, so we will have 10 outputs. BCD to 7 segment decoder, we have 4 inputs and 7 outputs in this case. 2 to 4 line decoder, 2 inputs and 4 outputs. So for 2 we have 2 inputs, so for 2 inputs we have these 4 possible bit patterns or codes: 0 0, 0 1, 1 0 and 1 1. So we have outputs y naught. Y naught is 1 when this bit pattern is present at the input. So this output will be 1 and the remaining outputs will be 0. For 0 1, for this pattern where a1 is 0 and a0 is 1, so for this code pattern y1 will be high and the remaining outputs will be 0. So if y1 is high, if this is y1 is high, so it means a0 is 1 and a1 is 1, so means so a0 is 1 and a1 is 0, so means 1, decimal 1 is present at the input. If we have this bit pattern at the inputs 1 and 0, so y2, for this bit pattern y2 will be high and the remaining outputs y3, y1 and y0 will be 0. So if y2 this line is high, so it means a is 1 and a0 is 0, so means 1 0 is present at the input, or decimal 2 is present at the input. 1 1, if both the inputs are 1 1, so y3, this pattern will be indicated by the y3 output. So this output will indicate this bit pattern, this code pattern at the inputs. These are the Boolean expressions. So y0, for y0 we have a 1 bar and a 0 bar because both the inputs are 0 0, so this is a product term. And this is for y1, this is for this pattern y1 is 1, so a 1 bar, a 0, so the product term is this a 1 bar and a 0. And similarly for this bit pattern, the y3 is high, so y3 is equal to a1 dot a0, so this is y3, y2, y1, y2. This is the logic circuit. To implement this circuit, so A1 A0, this is an AND operation, A1 and A0 through inverter. So for Y2, so A0 is applied for Y2 through inverter because A0 is 0, and for A1 this bit pattern A1 is 0, so A1 is applied to Y1 through inverter and A0 is applied directly to Y1, and for Y3 these two are directly applied. So this is the logic circuit for a 2 to 4 line decoder. 3 to 8 line decoder, so we have 3 inputs and 8 outputs. So this is again for 3 inputs we have 8 possible code patterns, 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. These are the 8 possible code patterns. If this code pattern is present at the input, then Y0 will be high and the remaining outputs will be low. If this code pattern is present at the input, so it will be indicated by Y1 or by this output, so it will be high and the remaining will be 0. And similarly, if this code pattern 111 is present at the output, so it will be indicated by the output Y7, so it is Y7 will be 1 and the remaining outputs will be 0. This is the implementation. These are the Boolean expression for each output, and these are the implementation. For example, for Y0 we have A is applied through this inverter, so if A is 0 this will be 1, B is applied through this inverter, this is B here, so B0, B bar is here, and this is C, and C is applied, this is a C bar here. So Y0 is equal to A bar, B bar, C bar. So if all these bits are 0 0 0, so this will be 1, this will be 1, this will be 1, and the output of this, only this gate will be 1 and the remaining outputs will be 0. So this is what the implementation of 3 to 8 line decoder. Binary to octal decoder. So binary to octal decoder is basically a 3 to 8 line decoder that we have discussed in the previous slide. Each octal digit in octal system, each of the octal digit is represented by a 3-bit binary. The binary to octal decoder has 3 inputs, 3-bit binary code and 8 outputs. Each output line will represent an octal digit shown in the block diagram. So we have 3 inputs and we have 8 output lines. So this line represent octal digit 0, this output line represent octal digit 1, this output line represent octal digit 2, this line represent octal digit 3, and so on. This is the truth table, this is octal, this is the binary 3-bit binary pattern of the octal 0, and for this, if this is present at this input, so Y0 will be high and the remaining outputs will be 0. So the function of the Boolean expression for Y0 is A bar, B bar, C bar. For Y1, if this pattern is performed octal 1, for octal 1, this pattern will be present at the inputs and Y1 will be high, this line will be high and the remaining outputs will be 0. So the output expression, the Boolean expression for Y1 is A bar, B bar, C bar. So these are the Boolean expression. This is what the truth table. To implement this, look, again we have the same decoder that we have discussed in the previous 3 to 8 line decoder. So a binary to octal decoder is basically a 3 to 8 line decoder. So this is a binary to octal decoder. A, B, C. Again, if this 0 pattern is present, so this output will be high and the remaining output will be 0. So this represent if this line is high, it means at input we have a 0 0 0. Octal digit 0 is present. The code of octal digit 0 is present at the inputs. If this line is high, and the remaining lines is low, so what it means, the code present at the input are 001, and it means the code of octal digit 1 is present at the input. So this is a binary to octal decoder. The BCD to decimal decoder. So as we have discussed, the BCD code of 8421 code represent decimal digits. It's a 4-bit code. So at the input of this decoder we will have 4 BCD bits, 4 BCD digits, 0, these 4 inputs. BCD code is 4-bit code, so the input will be 4, and decimal digits are 10, so the output will be 10. So each line represents a decimal digit. Of a 0000 is present at the input, so this line will be present, means the code of decimal digit 0 is present, is detected. This line detects the presence of the BCD code 0001. 0001 code is detected by this line. If this line is high, so means 0001 is present at the input. This is the truth table. So 0 digit, decimal digit, this is the decimal digit, and 0, 0, 0, 0, 0. The BCD of 0 decimal is 0, 0, 0, and the output or the expression for this y naught will be equal to a bar, b bar, c bar, d bar. For decimal digit 1, the BCD code is 0001. So y1 will be a bar, b bar, c bar, d. So this is what the implementation of this code. So for y naught we have a bar, b bar, c bar, d bar. For y1 we have a bar, b bar, c bar, and d. This is taken from here. And for y2 we have a bar, b bar, c. C is taken from here, and d bar. So this is y2. And for 9, for y3, y4, y5, y6 will be there. And for 9 we have 1, so a, and b bar, b is 0, and for 9, and c is 0, and d is 1. So it's taken from here. So this is the implementation of BCD to decimal decoder. This is the logic circuit. This is the logic circuit. Encoder. An encoder is a combination logic circuit that essentially performs reverse decoder function. It implements the reverse process of a decoder. An encoder accepts an active level on one of its inputs, representing a digit such as decimal or octal digit, and converts it to the coded output. So at the output we have a code, in the input we have symbols. In decoder, at the input we have code, at the output we have digits or symbols. Output level represent digits or symbols. Examples: octal to binary encoder and decimal to BCD encoder. So octal to binary encoder. Octal to binary encoder has in inputs because there are octal to binary encoder has 8 inputs because there are 8 digits in octal number system, one for each octal digit, and 3 outputs corresponding to the binary code. Octal digits are represented by 3-bit binary. So these are the 3-bit binary code of octal digits, and these are the octal digit at input side. This is a basic 8-line to 4-line encoder. This is how to design an octal to binary encoder. So this is a truth table for each octal digit. If a 0 octal digit, if this line is activated, asserted, then the code should be 0000. If this line is asserted, at a time we have to assert only one line, and active level will be present on one line. So for 1, this is 001. So if this line is active, then the code will be 001. If this line is active, the code at the output will be 010. So these are the binary values. The Boolean expression for a naught, suppose look at a naught. So a naught is active for this line, for this line, for this line, and for this line. For this line, a naught is active. So we sum it. 1 plus 3 plus 5 plus 7. So this is an OR operation basically. Similarly, A1 is equal to A1 is active in 2 or octal digit 2 3. A1 is active in this for this line, and for this line and this line. So 2 3 6 7 and A2. So this is the OR operation of line 1, line 3, line 5, line 7. This is an operation of line 2, line 3, line 6 and line 7, and A2 is the OR operation of line 4, line 5, line 6 and line 7. So look, A0 to implement A0, we have a line from 1, 3, 5 and from 7. For A1 we have a line from 2, we have a line from 3, and we have a line from 6, and we have a line from 7. Sorry, here we have a line from 6, from 6, and we have a line from 2 in these two ports, and we have a line from this one. So A1 and 2 3. So we also have a line in this from 3, from 6 and from 2, and A2 is active for these lines 4, 5, 6 and 7. So we have a line from 4, we have a line from 5, we have a line from 6, and we have a line from 7. So this is the MSB and this is the LSB. So this is what the implementation of a decoder. 0 is not applied to any gates. If suppose we want the code of 1, octal digit 1, so we will insert this, we will make it 1, and the remaining inputs will be 0. So look, this input will be 1 and the remaining will be 0. So this is an octal to binary encoder. The decimal to BCD encoder, this type of encoder has 10 inputs, 1 for each decimal digit and 4 outputs corresponding to the BCD code as shown in the figure. So these are the decimal inputs and these are the 4 BCD outputs. This is a basic 10 lines to 4 line encoder. This is what the table. This is a decimal digit 0 1 2 3 4 5 6 7 8. We have 10 digits and we have 4 bit BCD code. So these are the 4 bit, these are the outputs and these are the inputs. So we have 10 lines and we have 4 output lines. We have 10 input line and we have 4 output lines. The Boolean expressions for A0. So A0 is active for 1, for 3, for 5, 7 and 9. So A0 is equal to, the Boolean expression of A0 is line 1 plus line 2 plus line 5 plus line 7 plus line 7. This is the Boolean addition. So we will implement this and OR gate. 1, 2, 3, 4, 5 input OR gate. A1 is active for second line, A1 is active for third line, for 6th line and 7th line. So this is an 4 input OR gate, and A2 is active for these lines. A2, look at it 2. So it is active for 4, it is active for 5, it is active for 6, it is active for 7. So 4, 5, 6, 7. And A3 is active for only line 8 and line 9. So this is what the implementation. So A0, for A0 we have 1, we have 3, we have 5, we have 7 and we have 9. So these are the 5 inputs. A1, for A1 we have 2, we have 3, we have 5 and we have 6 and we have 7. For A2 we have 4, 5, 6 and 7, and for A3 we have only 8 and 9. So this is A3. This is the MSB of the BCD code and this is the LSB of the BCD code. So this is decimal to BCD encoder. Thank you very much. It's all for today.